Hi, my name is Paweł and let's do probably the most basic INAV tutorial for all of you who wants to fly flying wings with INAV, because today I will show you how to set up INAV for the flying wing so that it just gives you a more or less pleasurable experience without any bigger problems. Assumption for today that we have a flying wing already built, we have servos connected, we know to which outputs we want to connect a servo, or the flight controller is not yet connected, but we have it, we flashed it with INAV 2.0 and we are ready to go. First step, of course, connect with the configurator. After you do it, I strongly suggest after flashing new board is to perform the calibration. This is important, and the truth is you do not have to run the calibration after you installed the flight controller on your machine. You can do it just before. There are many tutorials how to do it, so let's just have a very short version of it without explaining what I'm just doing. I'm just moving the board to a different positions, pressing calibrate, and that's more or less all. I'm not doing this in a very good way because I'm not really paying attention. I will not be flying with those settings, so it's fine. After I really suggest you do it in a very careful way without really paying attention to all the angles and stability of the flight controller. It's worth it. Then let's save and reboot. Today I will be setting up a flying wing without a GPS. So I will not use any GPS related functions. So there will be no return to home and things like that. The most basic setup. The GPS setup will just go on top of what I showed you today. Calibration is done. We have the accelerometer gains, so we are ready to go. Step number two. Step number two is you have to choose your mixer and the platform time. I will be using aeroplane flying wing. So only thing I should do is either load and apply or load mixer. Let's begin with load mixer. It has the possibility to have two motors, but it really doesn't matter. Mine will have only one motor, so I can delete this motor mixer. And here in the servo mixer, there will be two servos on 3 and 4. This is very important. This number over here is, well, it's only a number. It's not output number. It's only a servo index. So it can be 3, 4, 0, 1, never mind. Just leave it on the defaults, and it mixes stabilist roll and stabilist pitch into those. I know some of you think that 50 in the weight is not enough. No, this is how it's supposed to be. It is supposed to be 50, not 100. It's supposed to be 50. So if you want full roll and full pitch, the servo is not saturated. Leave speed at 0, just like it is. Save and reboot. Reboot it, and let's connect. Haha, and now I disconnected. Mixer done. Now you have a choice. You can either use different presets, and yes, this will be working, or you can have a manual process, which I will show you today, when we will not apply any preset like flying wing of S800. We're just gonna set up everything step by step. Step 1. No, it's not step 1, step 3. Next step is we have to connect somewhere the radio receiver. How? It all depends on your stack, so I'm not gonna concentrate on that at all. Just probably if this is serial, you will have to use one of the UARTs. It will be probably one or something else, and all. Here, nothing. Like I said, it all depends on your setup, so do not pay attention to what I'm doing in this very moment. Reboot again. And now the magic begins. Let's go to the configuration. In the configuration, receiver mode, PPM, I'm just gonna set as bus without really paying attention to what I'm doing. And that's all. The Next step is to set up the board and sensor alignment. Because we are setting a flying wing, that means usually you will not have a magnetometer, and because gyro and accelerometer are right now tightly connected with the FC, probably the only thing you will have to set up is a yaw degrees. This means how many degrees in the yaw axis the flight controller is oriented. What we want is that when we pitch the flight controller and the aeroplane forward, the image over here also pitches forward. If we pitch left, roll left, then it rolls left. This is all. If it pitches in the correct direction and rolls in the correct direction, this is all. It's very, very good idea to do it while looking from the back of the aeroplane flight controller. If this is set up, we don't have to do anything else. Yeah, kind of important. The motors and servos will not spin if you will not set it up. Because we are using a flying wing, we really don't care about the ESC protocol, just leave it on standard, refresh rate standard. Servo rate. If you have regular 9-gram servos, then probably you really cannot go above 50 Hz. There are kind of pricey digital servos that can go up to 300 Hz, but if you are really not sure if you have the good servo, leave it at 50. The flying wings and the aeroplanes in general have incredible stability built in. We do not really need much of the refresh rate. Next interesting setting: do not spin motors when armed. Yes, we have an aeroplane. And because we have an aeroplane, we want to be able to stop the motor so we can glide, at least usually. And seconds until disarm is 0, because we do not want to disarm at the low throttle. Make sense? Makes sense. Usually you will also not have to change the minimum throttle, maximum throttle, or the command. And the next setting is the gyro configuration. I suggest going to 156 Hz. Why? Because it's just the best possible way to do it. Asynchronous mode off, and the flight controller loop time. It doesn't really matter much. It really doesn't matter much, because whatever more or less we're gonna set, it will be okay. If we set it to 1 kHz, then it will be really fully enough. Battery monitoring, it's right. Current sensor, of course, depending on which setup do you have. And over here, another important thing, permanently enable air mode. Yes, if you have an airplane, you want permanently enabled air mode. Always. Period. Done. Save and reboot. When we did what we did, and we have the motor output and servos and mixer configured, the next step is we have to set up the servo throw. If the servos and the control surfaces of the flying wing are moving in the right direction. What you will have to do in the servo page is probably you will have to reverse one of the servos. Which one? It all depends on your build and your servo, how your linkage is connected. So I cannot tell you which servo you will have to reverse, but probably you will have to reverse one. How to check which one? This is a high five test from the flight test. If you want to roll right, then the right control surface should go up and the left one should go down. If you want to roll left, then the left control surface should go up and the right one should go down. Like the control surface is giving high five to the stick when they are moving together. I hope you know what I'm talking about. And you want to pitch up, the control surfaces should go up. One of the servo that is not behaving in this way, it's reacting in the opposite way, should be reversed. Which one? It's up to you. Just click reverse on one and save and done. When this step is done and the control surfaces are moving like they were supposed to be moving, we can go one step forward. This time to set up the failsafe. You have, because like I said in the beginning, there will be no GPS on our flying wing today. You can leave it at land. When there will be a failsafe situation, the flying wing will just try to do not crash to the ground very much, and that's really all that we can do over here. So leave it at land as a default. Do not use drop, because drop will well go into completely uncontrolled flight and will not end up very well. RTH will be not possible since lack of the GPS, and do nothing. It was important in the previous version to set this to 0. It's not important that much right now, but I still suggest, just to be sure, set it to 0 and done. Save and reboot. With the failsafe configured, we can go into basic PIFF tuning. It's located, of course, on the PIFF tuning page. What you should do for the maiden flight: leave almost all the values over here in the PIFF tuning on the defaults. Why? Because if this is maiden, you really don't know how it will be behaving in the air. What I can really suggest is to slightly increase the pitch I to, let's say, 12 and the roll I to, let's say, 9, just to be sure that the I term will be able to counteract bad balancing, bad servo trimming, bad control surface trimming, or slightly misplaced the center of gravity. This should make the first flight slightly simpler, so it's a good idea to raise them only for the first flight. Later, when you will do the auto tune and servo auto trim, the procedure will just set completely different values. For the maiden, I suggest to slightly increase them. Now, the roll rates and the pitch rate. There is no yaw control on the flying wing, so leave it as it is. Usually, small flying wings up to 1 meter should be able to do without much problem 300, maybe even 400 degrees per second. For the first flight, I don't think it makes sense to really increase that, but let's say something around 300 should be pretty comfortable. The different story is with the pitch rate. The flying wings have very little pitch authority, and they really usually cannot do more than 200, and even that is usually too much. So if you will probably, let's say, change it to 120 degrees per second, it will be really very reasonable value. Roll angle and pitch angle. Once again, this is up to you. Flying wings do not have the yaw authority, so they turn only when they roll. This is why I'm usually not flying in the angle mode on the flying wing, so it's really hard to tell what to set up. If probably you will set up around 40 degrees, it still should be fine. I'm not using angle, I cannot give you really good advice over here, but 40 should be pretty much still the safe value. And now the magic. This, you see, gyro LPF cutoff frequency. With multi-rotors, you want this around 100, maybe even more. 60 is really the lowest possible value. It's not reasonable value. For the aeroplanes and the flying wings, go low. For example, my S800 flies the best with the gyro LPF frequency at only around 30-35 Hz. This allows not for the servos not to react for every single slightest change from the gust of wind. It improves smoothness. You can really safely move this gyro LPF cutoff frequency to, let's say, 35. It will be fine. Also, because we are not on the multi-rotor, leave notches alone, leave D-term filtering, yaw filtering, and all that thing. This whole section also has absolutely, well, almost absolutely no reason to be used by you besides the TPA. Throttle pitch attenuation. It works slightly different on the multi-rotors than on flying wings, aeroplanes in general, because it's not only attenuating at the higher throttle, but also lower, it's increasing the PID output when the throttle is below the threshold. I'm usually using value around 25. This is very low TPA. You will get your TPA value if you will notice that, for example, on the high speeds the wing starts to oscillate, or on the low speeds it loses authority. It all depends on your specific setup, and I really cannot give you the value over here. For the first flights, if you just want to check how the baby is going in the air, leave it at 0. You do not have to worry about that. Probably at one day I will make the separate video about TPA on the airplanes on the INAV, but not today. Let's save and advanced tuning. One more time, because we are not using a GPS on this flying wing, we do not have to worry about those settings, because there will be no automated modes. There is nothing we can set for the navigation engine to do, and all those settings of the position estimator, multi-rotor and RTH are almost not for you. Let's go to the modes and setup modes. For the maiden, I suggest to set up arm on one of the channels, set up angle on one of the channels, and set up maybe manual on one of the channels. And this is really all you have to do, because there will be no automated flight modes. You will also not be able to do any navigation, and that's all. Auto trim and auto tune. I've made a separate video about those two features, so the links are in the description. Please use those Please use those videos to know how to use auto trim, how to use auto tune. I will not describe this today. For me, when you do a first launch, it's good idea to launch in the acro mode. And acro mode is the mode when you do not have angle, horizon or manual enabled. It's the mode that provides you stabilization, but sticks control the rotation speed, not the position. It's probably the safest way to do a maiden, because the PIFF controller will take care of parts of the stabilization, will compensate for the trims, will compensate for the center of gravity. It should do just fine. Adjustment, nothing interesting. Servos, we already were there, nothing else to set up. Mission control, motors, OSD. If you have OSD, set up OSD. If not, then not. And there is one more setting that you might consider increasing for the maiden. Get iterm. It's called FW for fixed wing iterm throw limit. By default, it's set up to 165, and when you have trimmed airplane, it's fine. For the maiden, I suggest raising this to, let's say, 300. What it does, it allows the iterm to grow slightly higher. So if you really fucked up something with the center of gravity or with control surfaces throws, the iterm should be able to compensate for this error. If you did not do it right, and you have low iterm throw limit, the iterm might just run off the possibility to grow, to compensate, and you might have strange behavior in the gear. When you will set the auto trim and auto tune, I suggest going back with FW iterm throw limit back to 165 value, because it's a good default value. And that's all. Those are probably all the major, most important steps you have to take when you want to set up the INAV on the flying wing without any automated flight modes, without the GPS. In the future, I hope maybe in 2 weeks, or maybe even shorter, I will record a second video that will adds you the information which values you should check, change or set when you will be using a GPS and a barometer after all. In case of questions, suggestions, post them in the comment. That's all for today. Until the next one. Bye bye.